Assalamu alaikum. Welcome to the first draft of my project paper. I am SM Rakib Hassan, ID 2224138. My ST is Farah bint Hakapu and RA is Muhammad Humayun Kubir Mehdi sir. So in this paper we have tried to discuss an innovative simulation model for forecasting the stock prices in Dhaka Stock Exchange or DSE. It employs a multifaceted approach. I have tried transformer based approaches, generic machine learning algorithms, deep neural networks, NNNs, LSTMs, and GRU for this task. And whatever code I'm doing, I have added it to the abstract of this paper so anyone can access it. So let's move to the introduction. So the realm of financial forecasting has always been a fertile ground for the application of advanced computational techniques. So with the advent of more sophisticated machine learning algorithms, the potential to revolutionize stock price predictions has grown exponentially. So the Dhaka Stock Exchange, representing an emerging financial market, presents a unique and challenging landscape for such technological interventions. So this study is rooted in the exploration and application of advanced machine learning techniques, specifically transformers and deep neural networks, in contrast to traditional ML algorithms to model and predict stock prices within the Dhaka Stock Exchange. So we know the stock market is very unpredictable and volatile. So it is very tough to model. So traditional financial models often fall short in capturing the non-linear and dynamic nature of this market. So AI has opened a new horizon in this sector. In this paper, we tried ML techniques like transformers, deep neural networks, which have shown exceptional capabilities in other domains like NLP and image recognition. Their application in financial forecasting, particularly in a less studied market like the DSE, in both innovative and challenging. So with this, we also explore the performance of generic ML algorithms, which have been the backbone of many predictive models in finance. The core contribution of this paper will be the comprehensive approach to modeling stock prices in the Dhaka Stock Exchange using a range of machine learning techniques and in its analytical comparison of these methods. By doing so, it seeks to provide insights into the effectiveness of advanced AI methods in stock price prediction and to pave the way for future research and practical applications in financial market analysis. So there have been a number of previous works in this sector. So because the machine learning and AI community is growing, and people have applied these techniques in this market. So the first study conducted is a comprehensive study on the effectiveness of LSTM models for predicting the stock prices. So it actually tunes the hyperparameters and impacts the model's performance. It's highlighted in this paper. They also demonstrated this with proper configuration. And these LSTM models significantly outperformed traditional time series prediction models. It offered a more nuanced understanding of market dynamics. So another groundbreaking study was the DC-Gen or for forecasting stock prices. This research was very innovative. A class of AI models renowned in image processing was tasked to the financial domain. This study highlighted the model's proficiency in dealing with the noisy and volatile nature of stock market data, achieving superior forecasting accuracy. The empirical performance of the decision model was tested on FTSE MIB index, showing that it outperforms standard linear and nonlinear forecasting methods in both single-step and multi-step predictions. Next, we have the paper which presented a 2D CNN model specifically designed for stock trading. It leveraged the CNN's prowess for detecting intricate patterns and trends, a crucial aspect in financial trading. It showcased the versatility of the CNNs, extending their application from image to video analysis and to financial time series data. Another study was done on high frequency trading data, which underscored the importance of incorporating high frequency data like the limit order book information in predictive models. By applying CNNs to this type of data, the study showed how deep learning could capture the intricateness and rapid movements within the stock market, providing a more accurate and timely prediction of stock prices. The next one is a pioneering work that applies deep learning neural networks to the challenging task of predicting short-term stock prices movements in the Chinese market. It recognizes that stock market is a complex and non-linear system which requires advanced and flexible methods to capture its patterns and dynamics. It uses deep learning neural networks which are powerful and versatile to learn from high dimensional and complex data. The next paper proposes a novel approach to predict the future price of stocks using the transformer model. It uses new encoding techniques like time to vector to represent the time series features of the stock data. The time to vector technique transforms the time series data into a high dimensional vector space where the temporal patterns and trends can be better captured by the transformer model. The next paper examines the factors that affect the growth and performance of the stock market in Bangladesh using both primary and secondary data sources. The paper uses various statistical methods such as correlation and regression analysis to test the relationship between the stock market development and the independent variables. The next one, last but not the least, includes a novel artificial neural network model that combines technical and fundamental analysis to predict stock prices at stock exchange markets such as Nairobi Securities Exchange and the New York Stock Exchange. So, our research methodology is grounded in a rigorous and systematic approach designed to ensure the integrity and reproducibility of our results. This process encompasses a comprehensive suite of procedures, including meticulous data collection from the Dhaka Stock Exchange through exploratory data analysis to uncover deep market insights and careful data preparation to tailor the input for optimal machine learning model performance. So, we deployed a variety of advanced computational models, each subjected to a robust result collection protocol, followed by a detailed comparative analysis to elicit the efficacy of each model in the context of financial forecasting. This section describes each step of our methodology, providing a transparent view of the mechanics of our research. So this is the overview of our research. We collected the data, we performed the exploratory data analysis, then we moved on to data preparation. Then we applied 5 different computational models, we collected the results, then compared and analyzed the results. So the data collection process was a critical foundation of the study. For this research, we have accumulated the data from www.investing.com. We identified the DAC as the primary data source given its representation of an emerging financial market with unique characteristics. So this dataset contains 10 years of data from January 2013 to November 2023, providing a comprehensive view of the stock market over different economic cycles. So historical stock prices, including opening, closing, high, low, volume of trades were extracted. This was done using direct download features from the DAC or third-party financial data providers. Next step was the EDA, which is exploratory data analysis. It was the vital step for understanding the data and informing the subsequent preparation steps. We employed various visualization techniques such as line charts for stock price trends, volume bars, candlestick charts to assess the volatility and price movements over time. The descriptive statistics were used to summarize the data, including measures of central tendency and dispersion like mean, median, variance, and standard deviation. To identify potential relationships, we conducted a correlation analysis between different stocks and between stock prices and other market indicators. So important features like the stock price moving average, these were identified as model input. We searched for outliers and anomalies that could be due to market manipulation, data errors, or significant market events. And then we did the data preparation part where we faced several steps to transform raw data into a format suitable for machine learning models. We addressed missing values, duplicates, incorrect entries. Then the missing values are handled through imputation or deletion depending on their significance and volume. Stock price data were normalized to bring them to a common scale without distorting differences in the ranges of values. This is crucial for models that are sensitive to the scale of input data. These included technical indicators like moving averages, RSI index, and others that could provide additional insights into the market dynamics. We transformed the time series data into a supervised learning format where past stock prices were used to predict future prices. This involved creating lag features and restructuring the dataset accordingly. The dataset was split into training, validation, and test set, including the models would be trained on one subset of the data and validated and tested on unseen data. For models like RNN, LSTM, and GRU, the data were further processed into sequences to capture temporal dependencies effectively. So, by meticulously executing these steps, the study ensured that the subsequent machine learning models were trained and evaluated on high quality, well understood data, increasing the robustness and reliability of the forecasting results. So, in future, we will collect all the data and arrange a comparison and analysis part and discuss the future plan of our project. So that's all. Thank you for listening. Assalamu alaikum.